Okay, guys, today we are going to continue the new section which we started yesterday. We started in section 3, which is the limiting reactant and persistent yield. Okay, so we're still talking about the stoichiometric calculations, and we should know, okay, something called the limiting reactant and the excess reactant. So, anyone can remind me what the difference between the limiting reactant and the excess reactant, guys? Just okay.
Um,
Yes, Yasin.
the limited reactant has a small amount, and when it ends, the chemical reaction stops. And the other reactant, the excessive or exceeding reactant, there's a lot of it, but it doesn't react with it when the limiting reactant is يعني
Yep,
used.
good. So limiting reactant which represent the reactant which is completely used up during the chemical reaction. So like this, it control the amount of the other reactant that will be used, and also control the amount or limit the amount of the product that will be produced. Okay, which means the limiting reactant, okay, just represent, okay, or the limiting reactant uh, tell us how much of the product will be produced and how much of the other reactant will be used. So it means in the reaction, not all the reactants must be completely used up during the reaction. Some of them could be, or one of them could use up, and the other may still have some amount. So we call this excess. That means it still have so much amount that it doesn't involve in the reaction. Once we add more, okay, reactant, or the limited reactant is added more, okay, so it will resume the reaction and keep producing more products. So to clarify the idea here, guys, we stopped at this equation last time. Said carbon reacts with oxygen, producing carbon dioxide. So regarding to this equation, we said that, or what we could find out from this equation, who is the limiting factor in that equation, guys? Do you remember? What is the limit? Where is the limiting reactant here? Carbon or oxygen?
Carbon.
So carbon is the limiting reactant. How could we know that carbon is the limiting reactant? So simply we find that 1 mole, okay, of carbon that produce 1 mole of carbon dioxide, and 1 mole of oxygen, okay, that produce 1 mole of carbon dioxide also. So the ratio is 1 to 1, okay, carbon to carbon dioxide, or even oxygen to carbon dioxide. So here we, regarding to this, guys, we asking here, what would happen if we just mix 5 moles of carbon with 10 moles of oxygen? So actually, suppose regarding to the basic equation, the balanced equation, if I have 5 moles of carbon, they are gonna produce 5 moles of carbon dioxide. Yes, yes, guys, is it clear?
Yeah.
Yes.
And if I have 10 mole of of oxygen, suppose they produce 10 mole of carbon dioxide. But actually, in that kind here, if I have 10 mole of oxygen, suppose to have 10 mole of carbon dioxide of carbon to produce 10 mole of carbon dioxide. But actually, what I only have is just 5 mole, which means this carbon limit the reaction. It's just gonna combine with 5 moles of oxygen to produce 5 moles of carbon dioxide, and still excess 5 moles of oxygen will not react. You get this, guys? You get the idea? So here,
Yes.
this kind of analogy represents the idea for you. As you can find here, that's the 5 carbons, while here they have 10 moles of oxygen. So simply each mole of oxygen will combine with 1 mole of carbon to produce 5 moles of carbon dioxide, and still we have extra 5 moles of oxygen that they don't react. So like in that case, we say that carbon is a limiting reactant while oxygen is the excess reactant. So let's practice more, guys, okay, on this idea, or just to find out. So let's find here, he asks you, silicon dioxide, which is quartz, is usually quite unreactive, but react readily with hydrogen fluoride according to the following equation. And he just get the equation like this. So then he asked if 6 moles of HF is added to 4.5 moles of Si2, which is the limiting reactant. So who can tell me, guys? Who can tell me how we could work on this one? Let's try to think together. Okay. So yes, Hassan, let's work on it.
Yes.
Okay. Yes, Hassan.
انا ولا حاجه.
Hassan Gouda. You raised your hand.
ال HF limiting reactor.
How do you know?
1 mole of silicon reacts with 4 moles of HF.
I got 1 mole of silicon requires 4
Oh.
mole of HF. So how could you know? He give you here 6 mole of HF and 4.5 moles of SiO2. So how could you know which one is the limiting reactant? How could you know?
ما هو
Yep.
ما قلتها.
You said HF is the limiting reactant, yes? Why? What the reason? How could you know? The steps that you follow to predict or to find out that the 4
عشان 1 mole of silicon reacts with 4 moles of hydrogen fluoride to create one silicon to create one silicon dioxide.
Good. Okay, you said that 1 mole of these reacts with 4 mole of these.
ما قلتها الأول؟
No, just still wait a minute. You said 1 mole of these reacts with 4 mole of this. I agree with you. But how do you know that you are in the lab, you don't have plenty of these? Regarding to what is given, he said that you have 6 mole of HF and 4.5 moles, okay, of Si2. Okay, so that means already the HF is more than the SiO2. Okay, so what do you think?
Okay.
So here, good. Actually, Hassan, you did something good. You start to predict regarding to the more ratio of the reactants to each other. That's somehow a good sense of chemistry, but we need to find, okay, a rule, or we find steps that could help us. So we said that the limiting factor, that the factor which limit the amount of product. So we should find, okay, the more ratio between each reactant of these two reactants to the amount of the product. Okay, so let's see here. In regarding to this mole, each mole of SiO2, okay, produces how many mole of SiF or water? Just anyone, choose anyone. So 1 mole of SiF4. So in reactant, you can work in any product, okay, whatever the water or SiF4. So here, like this, 1 mole of these produces 1 mole of this. Okay, so regarding to this, he asked, how many mole do you have? We have 6 moles of we have 4 point mole. So if I have 4.5 mole of SiO2, so how many moles they supposed to produce from SiF4? Yes, Hassan?
4.5.
4.5 also, okay. So 4.5 SiF4. That's good. So like this, we find the more ratio. Regarding to the equation, let's try the other reactant. 4 mole of HF producing how many mole of SiF4? 1, yes? Hassan, you with me? Are you with me?
1 second.
Okay, so we said that regarding to the equation, 4 moles of hydrogen fluoride produces, okay, 1 mole of silicon fluoride. So regarding to what is given, suppose that I have 6 moles. So 6 moles of HF, actually they supposed to produce how many moles of silicon fluoride? 1.5, yes or no? So we are gonna find that 4.5 moles, which is already I provided with, they could produce 4.5 mole of silicon fluoride, but the 6 moles of HF just gonna produce only 1.5 of Si or silicon fluoride. So in that case, the reactant which should produce less amount of the product, that is the limiting reactant. So HF is the limiting reactant.
HF limiting reactant.
Yep. Okay, but what are the steps? Okay, you get the idea.
مفهومة يعني.
No, actually, in the exam, you should follow the steps to prove it. Okay, because actually, sometimes the equation doesn't, okay, or that you cannot find like this, because maybe I'm gonna provide you with, for example, the same equation. Okay, the same equation. If I told you that, for example, I have here about 20 mole. Okay. Okay, but here we have about 3 moles. So which one will be the limiting reactant?
Silicon.
So like that, it differs, although it's still the same equation.
Okay.
But regarding to the givens, here I have 20 mole. These 20 mole, okay, actually are gonna produce about 5 moles of Si, but these 3 moles just gonna produce only 3. So in that case, it will be the limiting reactant. You got the idea?
ماشي. Yes.
So I could just depend on the equation. The equation just give me the idea to find the ratio in which I'm gonna practice, or I'm gonna use the given amounts in the problem. Is it clear, guys? Guys, is it clear?
Yes.
Okay, so let's practice more. Okay, let's try here another one. So he asks you, okay, some rocket engines use the mixture of hydrogen N2H4 and hydrogen peroxide H2O2 as a propellant that reaction give us the following equation. So I give the equation as you could find here. So he was asked which is the limiting reactant in this reaction when 0.75 mole of N2H4 is mixed with 0.5 mole of H2O2. Okay, so who can answer this or who can work in this with me? Let's try, guys. Here. So again, he told you I have 2 reactants that are gonna produce this. So I should know which one of these reactants is the limiting reactant. If 0.75 of these reacts with 0.5 of these. Yes, Yasin?
H2O2.
So how could let's work on steps, guys. Actually, in chemistry, we don't predict like this. How could you know? First of all, we must
1 mole
yes, 1 mole
of N2H4.
So 1 mole of N2H4 that produces how much?
Nitrogen.
1 mole of nitrogen, yes? So we agree about this. So if you have 0.75, so 0.75 mole, they will produce of N2H4. They produce how many mole of nitrogen?
0.75.
So that's because the ratio 1 to 1, so it will produce 0.75 mole of nitrogen. Good. So like this, we know the amount of nitrogen that could be produced from the amount of N2H4. Let's find the other reactant. How many mole of hydrogen peroxide producing nitrogen?
2.
2 moles of hydrogen peroxide. They produce 1 mole of nitrogen. Okay. So like this, how many hydrogen peroxide is given? 0.5. Okay. So here
0.5.
Good. If we have 0.5 mole of hydrogen peroxide, so how many mole they are going to produce from that nitrogen?
1/4.
So 1/4, good. 0.25 mole of nitrogen. So in that case, which substance produce little amount or less amount of the product?
Hydrogen peroxide.
Hydrogen peroxide. So in that case, the hydrogen peroxide will be the limiting factor, while the nitrogen, the N2H4, or the hydrazine, that will be be the excess reactant. Is it like this, guys?
No.
Yes.
Okay, so here asks another question. He asks here, how much of the excess reactant in the moles remain unchanged? That means how much left of the hydrazine is not reacted. Okay, guys.
Half.
How could you know?
Because
we asked here, so regarding to this, let's check to this one. Okay, so we know that this one is the excess amount. So suppose that all the half mole of this will be used, yes or no? All the half mole of hydrogen peroxide is used. Yep.
Yes.
Yeah, so regarding to the chemical equation, 1 mole of N2H4 need to react with 2 moles of H2O2, yes or no?
Yes.
So if just what is consumed, the all I have and completely consumed is half, mole. So actually, how much of that will consume from the N2H4?
If only half.
Yep.
We have only half.
Yep.
It will take 0.25.
0.25. Yes or no?
5.
Yep. So that means the half mole of hydrogen peroxide just react with quarter mole of, okay, hydrazine. So actually, how much of the amount I have from hydrazine? I have 0.75, and I will consume only 0.25. So what is left is going to be 0.5 mole. You get it, guys? You know how to work on it?
Yes.
Is it clear?
Yes.
Yes.
Okay, good. So like this, he asked also how much each product in moles is formed, how many mole of nitrogen will be produced, and how many mole of water will be produced. Actually, we find how many mole of nitrogen will be produced. So why we choose this? Because we're working on the limiting reactant, because the available amount of hydrogen peroxide just will produce about 0.25 mole of nitrogen. So I can't use this because this is excess amount. That means it will not completely react. But what will completely react is 0.5 mole of hydrogen peroxide. So like this, we said that nitrogen, okay, the amount of nitrogen will be produced is 0.25 mole. Okay, yes, guys, do you understand this part?
Oh, yes.
So let's talk about the other one. How many water will be produced? Okay, who can work this? Who can tell me how many water will be produced?
Can
Yes,
I?
Yasin, yeah. So
1 mole
1 mole of what?
of water,
No. Let's. How did you know? Let's work it in steps.
because لو nitrogen we
2
only have
moles. 2 moles of what?
oh,
We are working on the limiting reactant always. So 2 mole of hydrogen peroxide producing how many mole of water?
4.
4. Okay, good. So here, how many or how much of the amount of hydrogen peroxide that we're gonna use? 0.5.
0.5.
Yes or no? So that's will produce how much water?
cross multiplication يعني.
Yep. So 0.5 multiplied 4 divided by 2 equal 1. So like this, we're gonna have 1 mole of water. You get idea?
Yes.
So that's mean here that half mole of hydrogen peroxide limited the reaction. It just allowed only that 0.25 mole of nitrogen to be produced and 1 mole of water to be produced. Okay, although we still have excess amount of hydrazine, but there is no more available hydrogen peroxide to react with. You get the idea? Is it clear?
Yes.
Is it clear, guys, for everyone?
Yes.
Yes.
Okay, so let's check here. He said that the black oxide of iron, Fe3O4, occurs in nature as a mineral magnetite. This substance can also be made in the laboratory by the reaction between red hot iron and the steam according to the following equation. And he provided the equation for you, as you can see. So he asks you, when 36 gram of water is mixed with 67 gram of iron, which is the limiting reactant? Okay, so be careful, guys, because he already provided you the amounts in grams. So what we supposed to do first?
Change it into mole.
Good. We must change them into moles. The grams must be represented into moles, because actually I cannot work within grams, okay, in a chemical equation, because the chemical equation represents a mole ratio, not a mass ratio. Okay. So in that case, we should supposed to. So we should first know how much this 36 gram of water represent how many mole of water. So let's work it. Okay, guys, who can work with me? 1 mole of water represent how many gram? So hydrogen is 1, so 2 multiply 1. Oxygen is, anyone remember how much is the mass of oxygen? 16.
16.
Okay, so overall it equals 18 gram. So 1 mole of water equal 18 grams. So what about the 36 gram? They represent how many mole?
2.
So they represent 2 mole. So like this, they are 2 mole. So that means here, instead of 36 gram, we are gonna say 2 mole of water. Let's find about the iron. Okay, so iron here, 1 mole of iron equals, anyone know? Do you know, guys?
تبقى 55
55
5
good, 55 gram, good. Okay, so that's 1 mole of iron. So what about 67 gram? They represent how many mole? So 67 divided by 5.5.
1.2
1.2 mole. So like this, I get it. So let's back to like this, that the first step, we convert the amount, the mass in grams into moles, or to find the number of moles of available material here. Let's find. Here we need to determine which one is the limiting reactant. So first we're gonna start with iron. So how many mole of iron do we have?
1.2
Here.
no,
regarding to the equation. So 3 mole of iron producing how many mole? You choose any product as you want. Produce how many mole? 1 mole of Fe3O4 iron oxide. Okay, good. So we asking here if you actually have about 1.2 mole of iron, it will produce how many mole of iron oxide? Yep.
0.4.
Yeah, 0.4. So it will represent 0.4 mole. Okay, so that's the first step. So we know that 1 mole of iron will produce 0.4 mole of this. Let's find here. What about the water? Okay, so regarding to the equation, 4 moles of water. Regarding to the equation, 4 moles of water producing how many mole of iron oxide?
1.
Good, Hassan. Okay, so in that case, if we have 2 moles, they're supposed to produce
0.5.
0.5 mole. Good. So which one is the limiting reactant?
Iron.
Iron. So iron is limiting reactant. Why? Because it just produces less amount of the product. So here, in that case, the limiting reactant is the iron. So here he asks you, what mass in grams of black iron oxide is produced? How many, mass of the iron oxide produced? Okay, so actually, regarding to the reaction and point A, how many iron oxide will be produced?
هيبقى 55 times 3.
No, just wait, pay attention. No, wait a minute.
Okay.
We asking here, he asked what the mass, of these in grams produced from the reaction. Actually, how many moles
From
of
the
this?
reaction of from 2 moles of 1.2 ولا 3 or 4?
What do you think? Which one we should use?
1.2.
1.2, because that's the limiting reactant. Already the iron, the 1,2 is completely run out, or they completely used, just producing 0.5. So that means we don't have enough to reach 0.5 moles. You get the idea? You get it, Hassan?
Yes.
So like this, what is produced is 0.4 mole. Good. So we need to find how much the mass of this 0.54 mole. So 1 mole of Fe3O4 equals how much gram? Let's find. So 3 multiply 55 plus
16 times 4.
Good, plus 16 times 4. So overall it equals
229.
229 gram, 229 gram. Okay, so like this. Okay, that's 229 gram. That's for 1 mole. So what about 0.4 mole equal? How much?
91.6.
91.6 gram. Brilliant. Okay, so is it all like this? The last question, he asked, what mass in grams of excess reactant remain when the reaction is completed? That means how much water left, okay? So, who can answer this one?
هيبقى 1.6.
Let's see. Just tell me steps. Always I'm talking with the steps. Okay.
هيبقى لسه 0.11 متبقي.
No. How do you know?
مش هو هنا
You are talking about Fe3. We're talking about water. We need to know how much left from the water.
ماشي.
So regarding to the equation, each 3 mole of iron will react with how many mole of water?
4.
4. Good. So actually the total amount that we have of iron is 1.2. Okay, so they will react with how many mole of water?
0.4.
So 0.4, that means 1.2 mole of iron will just combine with, okay, 0.4 mole of water. So the total amount of water which I have is 2 moles, which means, okay, 2 moles, I'm just gonna use 0.4. So what is left equal?
تقريبا غلط.
What again?
تقريبا غلط. هي فين المسألة
So
تاني؟
actually, yes, it's wrong. It's about 0.
هتبقى 1.6.
1.6. Okay, yes, yeah, that's 1.6. Good. That's 1.6. Yeah. Okay. So 1.6. So like this, I consume 1.6 of 2. So which means that I still have 0.4
0.4.
mole of water. That's the amount left. Yes or no? But he asked about the amount in grams, not in moles. So I must convert these moles into grams.
Yeah.
So 1 mole of water, H2O, actually we already calculated equals 18 gram. 18 gram.
0.4.
So 0.4 equal how much?
16.
So it equal how much? 0.4 multiply 18.
7.2.
Cannot 18 multiply 0.4. So I think 12. Yep. 0.4. So that's sorry. It equal
7.2.
7.2. Yes, 17.2. Okay.
No.
So 7.2 gram. That's the amount of water which is left. Is it clear here, guys? Is it clear?
Yes.
And I have a question here,
سؤال
guys.
بس أنا
Yeah.
عايز أفهم هي ليه يعني ليه الأيرون هو الليميتنج رياكت.
تمام. Look with me here, Hassan. How many moles of iron do you have?
1.2.
Once this 1.2 mole completely used, they will produce how many mole of iron outside?
0.4.
Good. How many mole do you have of water?
2.
And once they completely use, they will produce?
0.5.
So that means already the 1.2, they will be used up, or they will completely finish once the R0.4 is already produced. That means I don't have plenty of iron to react with the water to reach 0.5. You get idea?
Okay.
You get idea?
Yes.
For example, you have, okay, like for example, 3 papers, and you suppose that you are going to copy 6 pages. So actually, which one here considered to be the limiting reactant? The ink in the pen, or the number of the pages, or the number of the papers?
Number of the pages.
Yeah, the number of the papers, because you keep writing, the pages actually run out before you finish the amount. Okay, so here the idea. Good idea?
Yes.
That means the pages, okay, which you have, or the papers which you have, allow only to copy 3 pages, while the pen is able to make you write more than 3.
Yes.
You get it?
Yes.
Yeah. So any hard question regarding to this point, guys? So we're gonna stop at this part, okay? And next time, inshallah, we're gonna continue our lesson. We're gonna talk about, okay, we're practicing more and talking about the percentage yield, okay, next session, inshallah. Please study this part well from your textbook, and if you have any question, I'm waiting for your questions. Thank you and goodbye.